Hey, welcome back. In this mini lecture, I'll be talking about knowledge integration maps. What are knowledge integration maps? They consist of concepts and labeled arrows, and they divide the drawing area into discipline-specific areas. For example, if you're looking into biology, you divide it into various genotypes and phenotypes. As the last slide, it brings up the ideas of concept maps. Knowledge integration maps are different than concept maps. They're discipline-specific form of concept maps, while concept maps, they're a form of node link diagram for organizing and representing connections between ideas as a semantic network. So it's like concepts maps are a really big circle in the Venn diagram, and knowledge integration maps are sort of a smaller version of those. Here's the origins of KIMs, let's just call them that. They're based on principles of knowledge integration and the knowledge integration framework. It suggests that scaffolding students to have better integrate their ideas will support the conceptual changes in students' understanding. So knowledge integration maps help to, again, support conceptual changes so students learn more. You can support knowledge integration with KIMs as per the last slide. KIMs support knowledge integration processes of, first, eliciting a repertoire of ideas, then 2, adding ideas to the repertoire, then 3, sorting out the connections among these ideas within the repertoire, and then finally developing criteria for connections between these ideas. Knowledge integration maps can be used in multiple ways, and there are multiple uses. First, they're cognitive tools to help elicit concepts from the people who are making and using them. They're also social artifacts through which students communicate. These artifacts can make existing or missing connections explicit, and they can also spur discussions among students and teachers. And 3, they provide social support for prompting students to articulate their understanding and integrate knowledge through reflection. As a social process of reaching an agreement, it's critical in shaping and sharing reflections of connections between ideas as you're creating these knowledge integration maps and sharing them with your peers. Here's how to conceptually create a knowledge integration map. First, you generate a focus question. 2, you identify key ideas to allow the answering of the focus question. These ideas are based on field experts and textbooks, etc. Third, you structure the KIM drawing area into field-specific levels. As before, say if you're doing biology, you have genotype or phenotype, or individual versus population. In chemistry, you could have micro, macro, and symbolic. 4, you create a starter in knowledge integration map, and then 5, you create a KIM training activities to make sure that students know how to use them and interact with them. There are a number of limitations of KIMs. First, they do not include all concepts, only a selection. As a result, it's like a partial model of cognitive structure, not like a full one. This is similar to geographical or concept maps, which don't include all data. When you have concepts, you have 2 concepts that are limited to just one connection. As a result, you have to need to select between many possible relationships between various concepts. 3, you must learn to generate, interpret, and revise KIMs, and they're only effective after the training phase. It's something that students can do without training. 4, it's time intensive to generate and revise a KIM, especially if this is a less constrained form of a knowledge integration map or a larger map. Like the bigger they are, the harder they are to understand for some people. Related to 5, unconstrained KIMs can include many concepts and connections. As a result, again, they can be difficult to generate and revise. 6, interpreting KIM propositions can be difficult. Again, these 4, 5, and 6 are all sort of thematically similar. Experts and novices might use the same expressions, but with different meanings. As a result, they can be, because they're so sort of unique, they can be created and used and interpreted in multiple ways. 7, the interpretation and evaluation is challenging. 7A, there's could be an amorphous and an arbitrary structure for the KIM. It can mix different types of concepts. For example, a physical object can be included, a process can be included, an abstract construct can be included, property could be included, etc. 7C, it can include different types of links. These can be causal, correlational, temporal, part whole, functional, teleological, mechanical, probabilistic, and spatial. As a result, again, interpretation and evaluation can be challenging. Finally, 8, KIMs focus on declarative knowledge while other node link diagram forms focus more procedural knowledge, such as flowcharts. So again, KIMs are declarative, other ones like flowcharts are more procedural. That was knowledge integration maps. Thanks for watching. Looking forward to seeing you again soon.